This is Britt Caswell with another example video. In today's video, I'm covering example 5 from lesson 6-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to compare two logarithmic functions. And so our problem says that logarithmic functions can approximate the altitude of a plane over time, right? Because planes take off at a very steep angle and then tend to kind of flatten out a little bit, right? And they want to know which plane's altitude shows the greater rate of change over the interval. Now remember, when we have a rate of change, y'all, that just means slope. So we are comparing the slope of kind of a straight line between 2 points on this one where we have the equation and this one where we have a graph. So for both of these, I need that slope formula. Okay, so remember the slope formula is the change in the y value divided by the change in the x value. So what do we need to do? We need to find our change in y and our change in x. So for this plane A, what I need to do is I need to find, because I'm trying to find between 10 and 15, I'm trying to find a of 10 and a of 15. So what I've done is I have written these equations in Desmos, and I just need to replace, thank you Gyoza for your input, I need to replace the 10 and the 15. So on this one, you could see I have 31,184. And on a of 15, you could see that I have 34,914. So now that I have these two, what I need to do is actually calculate the slope between those points. So I'm going to say m equals, and I'm going to take these two values up top and subtract them from each other. And then I'm going to take 15 and 10 and subtract them from each other, which I've also put into Desmos just to save myself time. And you can see that it's 746. So what that's saying is that for every minute, this plane is increasing its altitude by 746 feet. All right, so that is plane A. So now let's check out plane B. So for plane B, I'm going to do the same thing where I'm calculating the slope formula. I just don't have to do it with, I don't have to calculate the y values because the graph already gives them to me. All right, so that's kind of the name of the game. So when I go over to Desmos, for plane B, I'm going to change my text color. I'm going to say m equals, so I'm going to take 39,449 and subtract 37,497 and divide it by 15 minus 10. All right, so if I go over to Desmos, I actually kind of have this layout, right? So I just have to change these numbers. So that first one was 39,449, and our second one was 37,497. And so on this one, it's a much lower value. It's 390.4. So the greatest rate of change over that interval happens with plane A. In fact, you could see it's almost double plane B's change. So what that means, if I were to graph it, it would come up like that. All right, so now it says, for which plane do you think the altitude will change more quickly over the interval 15 to 20? So if plane A is increasing faster between 10 and 15, it's also going to continue to increase faster over 15 to 20. And the reason why is because it creates a steeper logarithmic graph. Alrighty, so there you have it, y'all. That is how to compare two logarithmic functions. Until next time.